Hello everyone. In the last video, we're dealing with structural isomerism. As a continuation of that one, we'll be dealing with functional group isomerism. A separate video is done for this one as it seems to be an important topic. So let's begin with functional group isomerism. To make this functional group isomerism easy, we have divided this into 4 subtypes. In the first subtype, we have kept alcohols and ethers. We have done so because, see, generally if we represent alcohol, it is ROH, and if we represent ether, it is RO and R. So there is a difference of hydrogen and the R group in ethers and alcohols. So if we combining this logic, if we designate a general formula for this one, it will be CnH2n plus 2O. So if we put n equal to 1, it will be CH4O. Now CH4O, if we write like this, it will be COH, H, H and H. What it will be? It will become CH3OH. Comparing this one with this thing, which is ROH. Now in the same way, if we put n equals to 2 over here, it will be, now when we have placed n equal to 2 in the general formula CnH2n plus 2O, it will become C2H6O. So now if we arrange this molecule, it will be CH3, CH2OH and another thing CH3O, CH3. So the condition which we had taken first, ROH and ROR. So if any of the molecular formula is given which satisfies this general formula CnH2n plus 2O, should get to know that it should click in your mind that it can be a general isomerism, functional group isomerism pertaining to alcohol and ethers. So the molecular formula will be that of alcohol and ether. So you should cancel all the other functional group isomerism like COH and aldehyde and other thing, and come to a result that it is either alcohol or it is either ether, and calculate the number of isomers or whatsoever the question may be. In the next subtype, type 2, we have placed aldehydes, ketones, cyclic ethers, unsaturated alcohols and unsaturated ethers. Okay, so these all 1, 2, 3, 4, 5, these all will be this all molecular formula will be satisfied by a general formula CnH2nO. So if we put n equals to 3, it will be C3H6O. So it can be CH3 CH2 CH double bond O. It is an aldehyde. Similarly, it can be written as CH3 C double bond O CH3. Now it is a ketone. This one was aldehyde and this one is a ketone. So the general formula is satisfied. Okay. Further, with the same molecular formula C3H6O, we can manipulate it or convert it to other isomers like CH3 CH double bond CHOH. What is this? It is an unsaturated alcohol. Next, what is the next? We can convert it to a unsaturated alcohol by shifting this double bond over here. And next one, it can be an unsaturated ether. Unsaturated ether. Next one can be another unsaturated alcohol. Next, cyclic ether. This cyclic ether can be like this. C3, 3 carbons over here. Don't get confused with this one. And another cyclic ether being like this. And a cyclic, this is the 8th. Another one being this one. As said above, by using the general formula CnH2nO, we can transform them into several of isomers which is being aldehyde, ketone, unsaturated alcohol, cyclic ether. Then we have unsaturated ethers. This is the unsaturated ether. Okay, so by comparing this general formula, if you remember this general formula and apply it in any of the given multiple choice question, then you will be getting to know that the isomers can be any of the above said compounds. Now coming to the third subtype of this one, we have here carboxylic acids and esters. The general formula for this subtype will be CnH2nO2. CnH2nO2. Here always remember, in any of the general formula said above, the n value should be at least 2. If the n value is put as 1, then it will become CH2O2, which will be HCOOH. So as you are seeing here, if the n value is put 1, then what will happen is it will become any of the above component of the subtype. It will become any of them. Okay, so it is valid only for n equal to 2 and other things. So putting n equal to 2, we get C2H4O2, which will be CH3COOH ethanoic acid and HC double bond O CH3 methyl. It will be methyl methanoate, and this will be ethanoic acid. After discussing the major 3 subgroups, to mention some important thing I'll be telling, where are the formulas There are the general formulas which I have mentioned in the above three subgroups actually useful. And how are they actually useful? Where and how are they actually useful? To tell you, if there is an MCQ which is asking you the total number of isomers from the molecular formula, by using the general formula you can get to know what functional group isomer is left out. Like in the second group, as we saw, there were many subgroups, like there were aldehydes, ketones, unsaturated ethers, unsaturated alcohols. So unsaturated alcohols. So you can, if you by heart or if you remember the subgroups in the subtype and the general formula associated with it, you can easily correlate, or you can easily remember at the last moment that this particular isomer is left out, or I haven't counted this particular, what you say, isomer. So the number of isomers, you can calculate it exactly. The exact number of isomers will be in there in front of you. This is just a theory video. We'll be doing questions from the past years and get a clarity. Now the last one of the subgroups are which are least important, or the questions arrive lesser from these, will be 1 degree, 2 degree, 3 degree amines, which can be represented as 1 degree will be RNH2, 2 degree will be RNHR, and 3 degree will be RNR and R. This is one thing. The second thing will be cyanide and isocyanide. Just interchanging, you'll get two different isomers. So this should be kept in mind. These are different functional groups, right? Cyanide and isocyanide. And then we'll be having NO2 nitrite, like NO2 in this form, and N double bond O and NO2 in this form. So these are two different things, right? Then we'll be having alkenes. Don't be under the impression that alkenes and alkynes are not functional group isomers. They are functional group isomers. So you keep in mind that alkenes and alkynes are also functional group isomers, and still different things can be like alkadienes, bicyclo compounds, cycloalkenes, and bicyclo compounds. Lastly, I'll give a general formula for this one as well. Bicyclo compounds, it will be CnH2n minus 2. This is for alkynes as well, if you know this. Bicyclo compound CnH2n minus 2. This one, alkadiene, this can be the last one which I've mentioned, bicyclo compound alkynes and all. It can be also done by carbon, a double bond equivalence, which will deal in the near future. Double bond equivalence. This double, by knowing the double bond equivalence number, you can easily get to know how many structures can be formed. So the last subgroup of alkyne, alkadiene, cycloalkene, bicyclo compound, this can be done by double bond equivalence, or we can know about the number of isomers by this one double bond equivalence formula. So we'll deal with it in the near future.